In the previous lecture, we have studied 7 basic math operators as well as the assignment operator used for assigning values to variables. In this video, we look at more math operators that are available in Python. Operators are special kinds of tokens that represent computations in our programs. For example, the token plus represents the addition operator or represents the addition operation if it is used in the context of numbers. For example, 3 plus 7 is an expression that represents the addition of the numbers 3 and 7, which results in the number 10. Similarly, the forward slash represents the division operator. And if you write the following expression, 2 forward slash 4, this represents dividing 2 by 4, which results in 0.5. Note that these operators have a different meaning if they are used with a different data type. For example, the plus operator can be used with strings. And if you use it with strings, it will represent what we call string concatenation. And one example of that, if you take the string ABC and you concatenate it or you add it to the string 1, 2, 3, you will get the string ABC 1, 2, 3. Python comes with different types of operators. So in the last lecture we have seen arithmetic operators, and these are operators that are used for writing basic math expressions. You also have assignments and augmented assignment operators. So this equal sign here, this is the assignment operator. And we have seen that an assignment operator is used for assigning values to variables. So for example, if you have the statement x equal 23, this creates a variable named x, and this variable will point to a memory location that contains the value 23. In addition to the assignment operator, you have also something called augmented assignment operators, and these are all examples of augmented assignments. And an augmented assignment operator is basically a shorthand that combines both the arithmetic operators as well as the assignment operators, and we will see these in the next few slides. You also have relational and comparison operators as well as logical operators, and these are used mainly for Boolean expressions or conditional statements. So relational and logical operators are used to construct conditional expressions. And a conditional expression is basically an expression that have the value true or false. And we'll see these used quite a lot with selection structures and looping structures or repetition structures. So they are used with things like the if-else or loops such as the while or for loops. You also have membership operators, and memberships, these are used to test whether an element is a member in a collection, such as an element in a list. So it's used to test whether some element is a member of a collection such as a list or a dictionary, and so on. We have also identity operators, and identity operators are basically used to check whether whether two objects belong to the same type, or whether an object belongs to a data type or belongs to a certain class. And you also have bitwise operators, and bitwise operators are used for doing arithmetics at the bit level. Now for these two types of operators, so the last two types of operators, identity and bitwise operators, these are outside the scope of this course, so we will not be studying these two operators in this course, and they are subject to be covered in an advanced Python course. So we can take these operators and along with values we can construct expressions. And an expression is basically a sequence of operators and their operands that specifies a certain computation. Consider, for example, this expression in here. So this is an expression that is used for calculating the average of 3 grades. So for example, let's say I have 3 numbers or 3 values and I want to compute their average. The way you do that, you take grade 1 plus grade 2 plus grade 3 and you divide this by 3. So that's how you compute the average of grades in Python. Now if you consider this expression, you have in this expression the assignment operator, which is right here. This assignment operator has 2 operands, the one to its left hand side, which is average, and the one to the right hand side, which is this whole expression over here. Now for an assignment operator, the operand to the left hand side has to be a variable name. So this must be a variable for the assignment operator, and this can be an expression. And this is an expression because, again, if you look at this, this is again a sequence of operators and operands. So for example, you can take the division operator over here. So this slash here means division, and this division operator, it has 2 operands. The first operand is this one. So this addition of grade 1, grade 2 and grade 3, this is one operand, and this is another operand. So basically an expression is a sequence of operators and operands, and an operand itself is also can be considered, or an operand can also be an expression. So in general there are 2 types of operators in Python, and that's in terms of the number of operands that they take. So you have binary operators, which take 2 operands, and you also have unary operators, which take only one single operand. Most of the operators that we have seen so far are considered to be binary operators. Consider, for example, the plus operator, which is used for representing addition in Python. So the plus operator takes 2 operands, one to its left and one to its right. So for example, if I want to represent adding a number to a variable, so let's say I have a number here which called, for example, num of students, and I add to it, for example, let's say 4. So let's say I want to take a number of students, which is, let's say, some value, and I just want to add that to that variable, the number 4. So this plus operator here is a binary operator because it takes 2 operands. The first operand is a variable name, so that's a variable name. That's one operand, and the other operand is the constant, which is 4. So this is a constant, or a literal value, constant value. Similarly, you have the assignment operator, and the assignment operator again is an example of a binary operator because an assignment operator takes 2 operands, one to its left. Again, the one in the left is usually a variable name, for example, the variable x, and the one to its right can be an expression, for example, g1 times g2. So this is again, this is an operand, so this is the first operand, and that's the second operand. So binary operators take 2 operands, one to its left, one and the other one to its right. On the other hand, unary operators only take on a single operand. And one prime example of such operators is the unary minus. So unary minus, and the unary minus is basically the negation of numbers. So you can negate a number, or you can negate a variable in Python by using the unary minus before the variable name, and whatever variable name you give it, for example, minus var name. For example, let's say I have a value called num, and this value num contains 3.8, and if I do print and let's say I print minus and minus num, this is going to take the number 3.8 and it will negate it, and what I will get in the output, I will get in the output minus 3.8. This is basically an operator which take only one single operand, and the operand for this operator is this variable name over here. Okay, and because it only takes one operand, it's called a unary operator. Okay, so as we have seen in the previous slide, the two prime examples of unary operators are the unary plus and the unary minus. And the unary plus, basically it yields its numeric operand unchanged, so basically it doesn't make any changes to its operand. Consider, for example, the following statements. So let's say I have a variable, let's call it var underscore name, and this var underscore name contains the value 3.8. If you do print for var name, or if you do print for plus, so because I need to add the operator, so if you do print plus var name, what you get in the output is the following. So this is the output. So you basically get the number unchanged. You get whatever number, whatever numeric operand for the unary plus, you get it unchanged. So basically you get 3.8. On the other hand, the unary minus, it yields the negation of your numeric operand. So you will get the negation of that number. So to see how the unary plus and the unary minus work, let's take one example. So let's say that I have one variable, and this variable is called temp, and it contains the floating point number, or the floating point of minus 100. This is one example, or this is one place we are using a unary minus. So this takes the number 100, negate it, so it becomes minus 100, and then convert it to float. So I have the variable temp, and the variable temp contains the number minus 100.0. So it contains 0.0 because I am converting it to a float. Now if you do print for temp, temp contains minus 100.0, so plus temp gives you back the number unchanged. So the unary plus doesn't change the value. So this is going to print minus 100.0. So that's going to print minus 100. And if you print minus temp, so temp contains minus 100.0, minus the number, so it negates, and negating the negation gives you back the positive. So this is going to give you the value 100.0. And then we have this expression over here. So minus temp, so remember minus temp is 100, so this is 100.0, and 100.0 subtract from it 63. Now remember, Python will apply implicit conversion here because you have a float to one side. So this 63 here, it will be converted to a float, so this becomes 63.0, and 100 minus 63.0, you should get 37.0. And when you print the human temp, you will get 37.0, and that's the output produced by that code in the top. Now there are many times when you want to update a variable based on the content of the variable itself. Consider, for example, that I have a counter. So let's say I have a counter, and that counter starts with the number 0. And then each time I want to update this counter so it becomes 1. So this 0 gets updated to 1, and then this 1 gets updated to 2, and then this 2 gets updated to 3, and so on. Now how you might want to do, or one way to achieve that, is to create a variable called count or counter, and you set it initially to 0. Now if you want to update the counter, what you have to do, you have to update the variable itself. So counter has to be in the left hand side of the assignment, and then you need to take the value of counter, which is 0, and add 1 to it. And if you want to update it again, if you want to increase it now to 2, you can take counter and you can update it by taking the value of counter. So the value of counter is going to be 2, and you add 1 to it, now it becomes 3, and so on. So there are many times when you actually make an update to the variable based, so you update the value of a variable, for example counter, based on the value of the variable itself, or based on a previous value of the variable. Now Python has a shorthand for such statements. So if you want to make a change to the variable itself, you can combine these two operators together in a shorthand. So one way to achieve this statement in here is by doing the following, by saying, so you can take the value counter and you can do plus equal, and I need to update the variable by adding the value 1. So this statement over here gives you the same result of that statement over there. So basically take 1 and add it to counter. So these two are semantically equivalent. Now this operator in here, this is called an augmented assignment. So an augmented assignment is basically a shorthand which combines the assignment operator along with an arithmetic operator. And this is the general syntax for it. So you take a variable, you will have an operator, for example, a plus, a minus, a division, multiplication, and so on. And then after that is going to be followed immediately by the assignment operator, and then you will have an expression. And the value of this expression will be updated, and it will be either added, subtracted, divided from the content of that variable. And this is equivalent to this statement in here. So this is similar to saying variable equal the variable followed by the operator followed by the expression. So let's see examples of augmented assignments. So let's see one example or 3 examples. So for example, the count plus equal to, this is similar to what we have described in the previous slide. So this is equivalent, so in the long form is equivalent to count equal count plus 2. And if you have the statement here, fuzz multiply equal count divided by 2, so the thing to the right hand side of an augmented assignment can be an expression, and this is what we have, and this is equivalent to fuzz equal fuzz multiply, and between parentheses count divided by 2. And if you have this long statement and you want to convert it to an augmented assignment, so you take the variable name, this is the variable name that you want to update, because what I'm doing, I'm taking the old value and adding to it everything in here. So the way you do this is the following. So gamma, and the operator in this case is a plus, so that's plus equal alpha multiply a plus b. Okay, so this is the shorthand for, okay, so this is the long form, that's the long form, and this is the short form or the shorthand. Okay. So with this list of new operators, here's our updated precedence table. So remember, the highest power goes for exponentiation, so exponentiation is usually executed first before other operators. That's followed by the unary plus and the unary minus in terms of precedence. And then you have multiplication operators, so this is the multiplication, division, modulus, and floor division. And then you have addition and subtraction, and then last you have the assignment and augmented assignments. Now remember, you can always force the order of evaluation by using the parentheses. So for example, you can always do the following. So let's say I want to execute addition before, so let's say I want to do a raised to the power of b plus c, and in this statement what I'll have to do, I'll have to put b plus c between parentheses. So this is in Python, so this Python expression is equivalent to that math statement over here. So one concept we see in this precedence table that we haven't seen in the precedence table of the previous lecture is this concept of associativity, and this is what we'll see in the next slide. So when an expression has two operators with the same precedence, the expression is evaluated according to according to the associativity of the operator. So consider, for example, this expression over here. Now if you look at this variable, which is the y variable in here, it has two operators, one to its left and the other one is to its right. So it has this equal to its left and it has this equal to its right. So the question, which one of these operators will take on the variable y? Is it going to be the one on the left, or is it going to be the one on the right? Now if you think about it, because we are doing assignments, so what we are trying to do, we are trying to put inside the x the value of y, and we are trying to put inside the y the number 17. So in this case, this statement will be evaluated according to the following. So x is equal to y is equal to 17. So Python will start by executing that operator first, and then it will execute that operator, or the second the assignment operator, to the left hand of the y variable. So this would be the order of evaluation of this expression. So the variable y, it will be taken by the operator to its right hand side, and because of that, the assignment operator is considered to be one of those operators that has a right associativity. On the other hand, if you look at the division operator, so let's apply the same concept. So the value 2 here again has two operators, one to its left and the other one it's to its right. So the question, which one of these operators will take on the number 2? Is it the one in the left or the one in the right? And if you look at it, we have seen similar examples of this in the last lecture. You will execute this from left to right, and the division in here will be applied first. So this will be equivalent to 72 divided by 2, and that's divided by 3. So the number 2 will be taken by the operator on the left hand side. So that's why division has a left associativity. One note that you need to keep in mind, that sometimes in textbooks they call a right associativity operator, they call it a right to left associative. So the equal sign is right to left associative, and the division operator is left to right associative, but we'll use the shorter terms, which is right associative or left associative.